Good morning, HPA students, specifically my 8th graders. Today, I'm going to help you out distinguish the difference between a rational number and an irrational number, which is going to be the first part or the session number 1 of your math packets. Okay, so let's start first identifying what are rational numbers. Well, basically, if you talk about of rational numbers, these are the numbers that we knew from the start since you were elementary. You were actually being exposed to the different numbers that we knew in the elementary side, like whole numbers, like the counting numbers, um, whether it's going to be a positive or a negative number. We also have fractions. We also have decimals. So in terms of decimals, it can be terminating. So when you say terminating decimals, that means to say these are exact decimal. That it means to say that it has no continuation. It's exact, just like 0.5, 0.008, negative 2.5. So everything that is terminating. So it's not repeating. It doesn't have any pattern, but it's just an exact decimal. So it's called terminating decimal. Or it can also be non-terminating decimals, which are the one that is repeated, that has repeated digits, like 0.2323, 0.8 with a bar on top. That bar means to say that 8 is being repeated all the time, with 0.56 with a bar on top. That means to say 56, 56, 56. So it's continuous, but there's a pattern and there are repeated digits. So still considered rational. And lastly, not lastly, but we have option D. We got square root of 100, negative square root of 4. It becomes a rational number simply because if I get the square root of 100, and we know for a fact that square root of 100 is what? So what is that number that we actually multiply by itself twice that makes 100? Yeah, that was correct. It is 10, because 10 times 10 is going to be 100. So there is a square root of 100, which is basically 10. And I know for sure that 10 is actually a rational number because it's a whole number. So this square root of 100 becomes a rational number. Whenever you get the answer of it, it's going to be a number that is considered a rational number. Same thing with negative square root of 4. So when I say negative square root of 4, it means to say that the negative was outside, so it's fine. So we can put the negative here. And what's the square root of 4? Correct. That is 2. So that means the answer is negative 2. And I know that negative 2 is a rational number. So it means to say that negative square root of 4 is also a rational number. Makes sense. And lastly, those expressions that contains the pi. We know that pi is considered irrational per se. If you are talking about of pi alone, it is irrational. But there are times that whenever that pi is being expressed into a different form, just like pi minus pi. So it's just the same thing as 1 minus 1. It's just that we are using now pi. So pi minus pi is basically equal to 0. And we know that 0 is irrational. So this expression pi minus pi is going to be a rational number now. What about 4 pi over pi? So this means to say the over here is division. So when you divide pi minus pi divided by pi, that makes sense that it's going to be what? It is equal to 4. And 4, I know that 4 is going to be rational. So makes sense that 4 pi over pi is also rational number. Got it? Okay. Now we go to the side of irrational numbers. So what are the things that, or what are the numbers that is going to be considered irrational? So let's start with option A. We got square root of 3. You would notice that I have square root as well in here. So see the difference between a number having a square root, but it becomes rational, and the other becomes irrational. So when you take a look of square root of 3, can you identify two identical numbers, when you multiply together, it becomes 3? Definitely there's none. That's why it makes irrational. This is square root of 100. I can find a number that when I multiply by itself twice, it's going to be 100. And we said that it's going to be 10 because 10 times 10 is 100. But I could not find anything with 3. That's why square root of 3 now becomes an irrational number. Same thing with square root of 11. I cannot find two identical numbers that makes 11 at the end when I multiply. Same thing with square root of 37. Yeah, it might be close to square root of 36, which becomes a rational number because 36, that's 6 times 6 is the square root of 36. So basically, the square root of 36 is 6. But square root of 37, I don't have. That's why it falls under irrational number. Let's go to option B. You notice that it's going to be a decimal number, but I also have decimal numbers on my rational side. So what's the difference? When you take a look at the example of a decimal number under irrational number, it gives me the idea that this 3 dots actually is a continuous number. And looking at the numbers I have, it doesn't have a pattern, it is continuous, that's why it falls under irrational. So if it's a decimal number, as long that decimal number is continuous and it doesn't give me a pattern at all, there's no repetition of digits, and there's no pattern of it, then it's going to be irrational. Same thing with 0.6813495, no pattern at all, and it's continuous, so it's going to go with irrational number. And lastly, with those numbers that has the expression of pi. Pi plus pi is going to be what? 2 pi. So there's 1 pi in here, there's 1 pi in here. So 1 plus 1, that makes 2 pi. And we know for sure that this pi is irrational. So an irrational multiplied to a number 2 will definitely give you a number, a decimal number that is continuous and has no pattern. That's why it's called irrational. Square root of pi. When you get the square root of an irrational number, definitely it gives you an irrational number as well. And even the cube root of 2 pi. If you get the cube root of 2 pi, since you know for a fact that pi is irrational, in getting the cube root of it, definitely it gives you an irrational number. I hope that this tutorial that I made would help you out distinguish the difference between a rational and irrational number. Have a good day.